Hi, everybody. I guess we'll start. So first of all, thank you all very much for coming. So my name is Peter Goskowski. I'm here at ORNL, and we're going to start with this brief introductory talk, and we're going to do this together with Sebastian from AWS. So the idea for the talk is really just to tell you a little bit about what this working group is, as well as tell you a little bit about what the plan is for the rest of this session and then the afternoon session. So the group is called the working group is called the Workflows and System Architecture. Of course, this is part of the openQSE effort. The group is led by Johannes Blaschke, who unfortunately could not make it here, so you'll have to listen to us. Sorry about that. So here's a list of things that we're exploring and sort of trying to understand as part of this group. So one is application workflow pattern analysis. So here the idea is basically to map the different types of hybrid quantum classical applications onto the different resources and trying to understand what part needs to utilize quantum versus classical. Sort of a follow-up to that is trying to understand what the constraints are in terms of different resources. So latency constraints, throughput demand, synchronization, things like this. And then this last point, driving, I can actually point to stuff, driving system requirements, that's really about trying to understand how we can connect some of the stuff that we're doing above to maybe some of the other working groups. Okay, so this just in general, this integration of HPC and quantum is just a very hot topic. All the major players are thinking about this in one way or another. I just sort of point out a few, list a few sort of fairly recent or maybe not so recent sample of publications that have been done in this space. Apologies if yours is not in it, but everybody's thinking about it in a slightly different way to some extent, and there are different institutions, they have different requirements, they may have different hardware, but part of openQSE as well as this this working group is to understand whether we can find some commonalities between all of this. And part of the game really is that if we do, we think that this shared knowledge can help interoperability later on. And hopefully it can speed up development as well. And that's, some people sort of argue the opposite, but I think for many things like this, sharing knowledge is beneficial. So things that we might want to sort of converge on things like terminology and concepts, identifying, for example, primitives in some of the application workflows that can be then shared with other people and reused. And then I'll give.
Yeah, thanks, Peter. So thanks for setting the scene here. I also want to add a couple of thoughts to basically stimulate discussions later on. This will be a very discussion-heavy session. And I usually try to not make very cluttered slides, and I often fail, as you can see. But that at least resembles a little bit, I think, the complexity I see in the, in what it really takes to integrate quantum and classical computers, or quantum and HPC. If we look at it from a bottom-up perspective, then I think the first question we are interested in as a working group is, how are these systems actually then deployed together? And then that is obviously affected by any kind of or geolocation requirements. Are there geolocation requirements? If yes, why are there geolocation requirements? Is this because workflows the users want to run require have specific latency requirements for the round-trip latency of communication between quantum and classical systems? Or are these maybe other, are there other reasons we overlook here? If we have any blind spots, this is why we want to have a discussion-heavy session today. So please, input also your experiences and your expectations. So then, let's say if we need co-located systems, then the next question that comes up is how tightly actually these systems then need to be integrated. What interconnection requirements we have, and why do we have these? Can we realize these over wide area networks, over local area networks? Do we need specific interconnects, high performance interconnects? All that is, all of the players out there that have made their thoughts about this, like Peter said, have opinions about this, but we want to review these as a working group together, I think. And then in the end, it's also, in my opinion, not just the question how we deploy these systems, but also how we abstract all the layers in the stack. And these will inform, as I believe, again, then the system integration requirements we want to report out. So what we think we want to do in this working group is we want to go from applications, from example applications, to identify workflows and workflow patterns, and then move on to system requirements. The workflow patterns we are interested in are essentially the sequence of operations that are executed in the quantum classical workflow, and then also the data flows. And then we try to map these onto integration patterns that then in the end hopefully inform us how these components should be deployed and how these components should be coupled. There's one thing I also want to inject here. So we at AWS, we have done a collaboration together with colleagues at NVIDIA and NERSC and NASA Ames, and we kind of pushed this out, I think, on Monday, or was it on the weekend? And this is kind of our suggestion, how we can actually quantitatively reason about integration requirements from a performance standpoint. So we have proposed a performance model for hybrid quantum classical workflows that is essentially a runtime model that allows us to decompose individual compute cycles in a hybrid workflow, and then map these or decompose these into classical compute requirements, into quantum compute requirements, and communication requirements or compute costs. And then what we did in that work is we applied this to two levels, or we looked at two different distinct levels, the application level and the real-time level. At the application level, what we came up with was kind of a metric for a computation to communication ratio, and that we think allows us to actually diagnose exactly these integration requirements, or more specifically, let us identify whether a certain workflow is compute heavy or is communication sensitive. And at the real-time level, maybe it's a bit more obvious. I mean, that model then gives us a feasibility constraint that determines rather if a certain execution is possible rather than what's the time to solution. And the key insights we found out in this paper when we applied this to specific target workflows was that actually we see very little benefit for co-location on the performance side when it comes to compute sensitive or compute intensive applications. There is definitely a crossover point when you can reduce the compute costs. You move over to the latency or communication sensitivity of the spectrum, but then obviously tight integration remains crucial for real-time tasks like quantum error correction. So we would be super interested in getting your opinion, and also if the working group may want to adopt that and build on it when it comes to their system integration studies. Okay, so these were the thoughts I just wanted to add and inject. And now I think Peter will tell us a little bit about what we're going to do today.
Yeah, so this is the agenda for the next couple of sessions, right? So the morning on the left, afternoon on the right. So after this talk here, we'll have Chris from ORNL we'll give you an ORNL's perspective on this. And then we'll have 3 talks about sort of specific application types and how they map. This will be done by Smitri, Namit, and Tyler. And then in the afternoon session, I will start with another lightning talk, which will discuss a little bit the quantum error correction and how that fits into the story. And then we'll have some discussions from Laura, who I think she is not here yet. She's got a heroic travel schedule, but hopefully she can make it. And she will lead a discussion on non-performance related requirements. And then after that, we will sort of see how it goes. But we thought that maybe we'll still touch base on things like overlap with other working groups and whether we can set some sort of milestones. And what I want to highlight is that after every talk, almost every talk, except for this one, we hope to have maybe a 15-20 minute discussion that sort of pertains to the talk. So one thing to point out during the discussions, whenever you're trying to speak, we have, I think, 4 microphones. So we will run around or maybe pass the microphones to somebody else, because the ultimate goal is that we are recording this via Teams. And then at the end, we'll give the transcript to AI and maybe we'll come up with something interesting. We'll see. And then we'll have 2 moderators for each of these. And I did want to ask if I'm going to try to take notes whenever possible. If there's somebody else that is willing to take notes every now and then, just in case the eye doesn't catch everything, then it'd be great.
Exactly. Okay. So and then now, as Peter said, I mean, we're gonna have a lot of whole room discussions. This is actually what we want to achieve here. We want to get your input. We want to get your thoughts. We don't really steer the discussions a lot, I would say, but we decided we come up with a slide and have a couple of provocative statements, and I have the honor to present that slide. So this is really just, I mean, to stimulate disagreement maybe in the room. So this is what we thought could be interesting to seed conversations. So the first statement is that, well, actually, if we look into the workflows, specifically the user land workflows maybe, then all what we know today is we actually don't need HPC in hybrid workflows. I don't know. The other thing is that, do we really have evidence for end user applications that require tight integration? I mean, think about that when we kind of discuss individual workflows today and when we discuss potential system integration requirements. And also finally, probably most debatable, for quantum classical systems, right? So when we talk about tight integration, I mean, what do we actually mean with tight integration? And then we thought, okay, for quantum classical systems, do we really think tight integration requires co-location? I mean, it's kind of obvious for the classical case, but will it be like that for the quantum computing case? Let's see.